For this hackathon, NextBridge Analytics decided to develop a new features to the MapTrends service to showcase its unique abilities. MapTrends is a new standard for insight into mobility, utilizing mobility analytics algorithms of tomorrow developed by our data scientists. The collaboration with Telenor enables us to demonstrate exactly what such a partnership will bring to the field.
For many around the world, waiting for public transport is an annoying and frustrating experience. It only takes 100,000 people in a city to wait 5 minutes to collectively waste 8,000 hours per day. Even if we could only make public transport a few minutes more efficient, it would lead to many thousands of hours saved. And that is not counting the inconvenience experienced by commuters.
We want to solve the problem of commuting and public transport by combining open source tools like R and Python together with the SAS Via platform and its powerful SWOT API. In this use case, our awesome data scientists have used data from OpenCell ID, OpenStreetMap, in combination with our own collections of data in partnership with Telenor.
We partner with NextBridge Analytics for this hackathon to better understand how our mobility data may help our consumer-related services. Our user is not directly related to commuting, but we see a new and exciting value.
At NextBridge Analytics, we have developed a solution called MapTrends to help commuters and municipalities all around Norway. This service currently ranks all the commutes in the entire city of Oslo based on how long they take, how many bus changes there are, bus stops, and detours from the fastest route. We then weight them by how many people take each commute, providing a quantified list of the very best commutes to the very worst commutes to our customers.
But how do we get all this commute information? Only telecommunication providers have the volume of data required to characterize all commutes over a city or an entire nation.
MapTrends collects anonymous movement patterns of an entire city or even a country. Here I've made a visualization on SAS Visual Analytics of my commute yesterday by logging all the towers my cell phone connected to. To make this, we have sourced OpenCell ID to synthesize the data available to telcos. The raw data, however, is quite messy. It is definitely nowhere GPS quality.
From OpenCell ID we have the cell coverage around Oslo. And these circles here represent the cells that this person has been connected to on a journey from his home to his work. If we first connect to this cell over here, we make an assumption that he's in the cell. However, after a short time we see that he's connected to the second cell. Based on this information we can deduce that he's probably in the overlap between these two cells. So we place him here at this time. Continuing like this, we see him later in the third cell, which is a little bit further over here. Again, we place him in between these two cells, assuming that's probably where he were. If we continue like this, we can track this person from his home all the way through the cells to his job. Let's take a look at this commute. Here you can see the probability shown as a heat map, which we use to calculate the trip metrics. Of course, if you have millions of trips, this is computationally intense, so we leverage the power of the CAS engine on SAS Via.
Process this trip for an algorithm that outputs metrics and statistics based on this trip. Here are some examples, such as the distance you would have to travel if you took the bus, versus the distance you would have to travel if you just went the most direct path, e.g. by car or by walking. Also, how many bus stops you would have to go via, and how many minutes that whole trip would take. And also how far the bus deviates from the most optimum trip. Here you can see I've calculated the 4 most common commutes to our office at NextBridge. The Vejbed to office commute took 10.4 kilometers and had a detour distance of 4.7, so almost half the trip getting to the office by bus goes opposite or away from the most optimum route. The Lysaker to the office trip is almost the same distance at 10.5 kilometers, but the detour distance is only a fraction of that, and the number of buses they would have to take would only be 1 with 21 bus stops. I've also calculated this from the Winterboro to the office, which has the longest trip, and the Serenga to the office, which is essentially just down the road at 3 kilometers, but yet still has to take 2 buses. I've combined all these metrics into a single bus commute KPI version 0.1, which is simply the detour distance divided by the number of commuters times by the bus distance. Here you can see the Weitweg to the office has the worst commute, and the Lysaker to the office has the best commute. That's because it travels relatively far with a few number of bus changes and doesn't have a large detour. From this, we can then provide our customers with a simple, easy-to-use metric to find out where and when or who has the best and worst commute.
By only exposing the metrics and statistics of bus routes via the SAS API, we ensure that users' data is kept private and secure. Armed with anonymous insight from our API, transportation companies can easily find where their services are failing, the most people, the most time, and understand the total cost of the inconvenience measured in hours. The insight derived from such analytics has many more areas for the betterment of society and businesses alike. It enables smarter cities and smarter roads based on actual demands. It lets planners understand where people naturally move, both how and ultimately why.
Today, Telenor and other telcos need to monitor and analyze important customer information in real time to ensure that they are making optimal decisions. This includes information that impacts on the total customer experience and the voice of customer. This capability enables Telenor to promptly react and, most importantly, distinguish between high and low value customers and good and bad experiences. Combining all our customer data with anomalous insights from network data like we have seen here provide a 360 degree of our customer and enable appropriate analytical driven actions to enhance our offering to our users. Being able to deliver these offers consistently across all channels, both reactively inbound or proactively outbound, can be the difference between a fall in ARPU versus protecting your most valuable customers. This can encourage them to stay loyal and increase their value during their customer journey. Using this SAS Via platform and this hackathon, we will now dig deeper into how we can leverage mobility analytics for better customer experience.